So in this video, I'm going to show you how to create a spreadsheet simulation of projectile motion. So for example, we will create a spreadsheet involving this cannonball launch. So we've got an initial speed, 25 meters per second, with an angle to the horizontal of 37 degrees. So we enter in our initial velocity and our degrees 37. Now I'll just make a note that Excel trig functions use radians, not degrees, so we need to convert that. So to convert degrees to radians, we use a function, so equals radians, and we select the cell we want to convert. Okay, so acceleration due to gravity on Earth is minus 9.8 meters per second squared. So we want to now resolve our initial velocity into the horizontal and vertical components. So we use the formula ux equals u cos theta for the initial horizontal, and uy equals u sine theta for our vertical component. We select u, the initial velocity, and then we type the function cos, open brackets, and theta in this case we'll select the radians, not the degrees, and close bracket, and then equals. So that's correct. Then for the initial vertical velocity, again, we go equals, select 25, and then this time we want sine theta in radians, and okay. All right, so we can change the number of decimal places, just tidy that up a little bit. Maybe 3 sufficient. Okay. Okay, so next we need to start entering in our values here. So we're going to put a range of times, say, to just over 3 seconds worth, and we're going to step it in increments of, say, 0.05. So to do so, we type in 0 for the first value, and then we type in 0.05. Okay, and a little trick here is to select both values, and then when it changes here, and then it changes to a cross, and we drag down. Yep, that should be fine. So now we want to enter in the vertical and horizontal velocities for each moment in time. So we can use these equations here. So your final velocity equals the initial velocity. This is your horizontal velocity. Notice it stays constant. It doesn't change. So we simply, if we go equals, and then we go up to our initial horizontal velocity and select that. If we use the F4 function at the top of the keyboard, press F4, and you'll notice here it puts in $signs in front of the column value G and in front of the row. So that fixes that. So if we then go to copy, drag this formula all the way down, it will remain at this this cell here. So I might just, okay, so we drag it. So now we're going to enter the formula for the vertical velocity. So we just follow this. So if we go, so Vy equals Uy. Okay, we want to make sure that that stays constant all the way down. So again, we press the F4 button at the top of the keyboard, and it will put those dollar signs. So if you can't work that out, just put the dollar signs as shown here. Okay, so we go plus, and we want our acceleration due to gravity. So I'd probably put brackets here just in case. So put bracket, select the acceleration due to gravity, and because we want that to stay constant, we press the F4 button. Okay, and then we times that, so that's our asterisk, and times time. So we just go over and we select this cell here, leave it relative so that we don't need to press the F4 button, and then we close our bracket and then press enter. So it should be about, all right, that's correct. Okay, now if we get our cross, and we're going to drag this formula, and it's going to copy it all the way down. So we click and drag. Okay, so we're just going to come over here, and we're going to complete these equations here. So we've got the delta x. So you see from the formula, delta x equals ux times t. So this is our initial horizontal, and we want that to remain constant. So we need to go equals, and we select ux, and we make it absolute by pressing the F4 button at the top of the keyboard, and then we times it by time, and then enter, and then we select that cell, get the cross up, and then we copy it all the way down. Okay, so now for displacement in the vertical, so we use this formula here. So dy equals uy, so we select uy and make that absolute, times, okay, so obviously that's going to make that value here 0, but anyway. Okay, what I might do is put some brackets in, then we go plus, and have another bracket, and we've got a half, so we make that 0.5 times acceleration due to gravity, make that absolute, and then times the time again. Okay, and if we put a little, so if you find the key for number 6, and if we press shift, that you'll find that little pointy hat, that's our superscript. So we need to put pointy hat 2, and that will square the time, and then close bracket. All right, so click the cell, and we're going to copy that formula all the way down. I'll just check that it's okay. Yes, it seems to be fine. So copy all the way down. Okay, so we'll just leave that as is for the moment, and the next video we will continue.